Hello dear students, today we are going to study or learn a very important and interesting topic from organic chemistry, that is synthetic dyes. Synthetic dyes, this is a most colorful topic from organic chemistry. It is involved in the syllabus of BSc third year in the 6th SEM. Dyes are nothing but the colored compounds. If there are no colors in our life, then imagine how is our life. If no colors in the life, then the life is not so beautiful. If there are no colors in the butterfly, then imagine how that butterfly is boring. If there were no colors at the signal, then imagine when we will stop, when we will go, and when we will ready to go. So without colors the life is boring. So colors only makes our life very beautiful. So today we'll discuss about the chemistry behind the dyes. Now see, these are the colors. Now these are the colored compounds. But remember, all color compounds are not dyes. Only those color compounds can impart its color, or only those color compounds fix to the fabric, fix to the substrate, and they will not wash out with water or will not fade by light. Hence, these compounds only called as dyes. So we can define dyes are the organic compounds which have an ability to impart its color to the substrate. Now substrate may be the fiber, it may be fabric, it may be plastic, it may be hair, it may be food. So we can give color to the hairs, we can give colors to the fabric or fiber, we can give color to the plastics or dyes to make it attractive. We can give color, or we are using colors to the food for making food attractive. We are using colors for many more articles. So apart from these, dyes can be used as an indicator for titrations. Dyes can be used as an bactericidal, example protonsil. Dyes can be used in histological studies. Example, safranin is used for histological studies. We should know which dye should be called as a good dye. A good dye is one which should have attractive color. It should give wide range of shades. It should be permanent. It should be cheap. Anyone can afford it. It should be safe while handling, and it should be easy to apply, and it should be fast to light and washing. Here fast is nothing but it is a property of a dye, or it is ability to remain unchanged. Then we'll see classification of dyes based on their origin. So basically in previous age, the dyes are obtained from nature. So when they are obtaining from nature, if they are obtaining from plants, then these are the plant dye, animal dyes, and if they are obtaining from minerals, these are called as mineral dyes. From plants, the dyes, mainly indigo is the first dye which is obtained from plant. So this is the indigo plant. From this plant, on fermentation, it gives indigo dye. Alizarin is a dye which is obtained from madder roots. Then lac is one dye which obtained from the insect. Insect secretes one resinous material, and which is called as lac dye. And minerals like iron oxide, which is obtained from mine, ferrous sulfate, which is obtained from mine, it is also a colored compound, can be used to some extent as a dye. Now synthetic dyes. Scientist William Henry Perkin firstly synthesized or firstly discovered. This is an accidental discovery. He discovered the first dye, which is called as mauve, or it is also called as mauve dye, which is obtained from coal tar. At the age of 18 only, this scientist has discovered this dye, and it is having purple color. Now these dyes, depending upon the sources, they are divided into two types. One is natural dyes and another is synthetic dyes. Natural dyes have some advantages because it is safe, it is biodegradable, and it is bright colored. But it is expensive, it needs more complex procedure for application, and it has limited shades. So these natural dyes are nowadays replaced by synthetic dyes. Now synthetic dyes has attractive colors, they offers wide range of shades, it is permanent, it is cheap, it is easy to handle, but it has one disadvantage, that is it is non-biodegradable. And nowadays synthetic dyes are used everywhere for the applications for dyeing textiles. Now there are different theories explaining color and constitution of the compounds, mainly molecular orbital theory, Armstrong's theory, Phenolphthalein theory, and Witt's theory. In this topic we will discuss about Witt's theory of color and constitution. Now see, here is one compound, acetone, and here is another compound, that is diacetone. Acetone is colorless but diacetone is yellow. So scientist Witt states that as physical and chemical properties of the compound depends upon the constitution of the compound, structure of the compound. Similarly, color of the compound is also related to the structure of the compound. So according to this theory, color of the compound is mainly due to the presence of unsaturated group known as chromophore. So the unsaturated functional group like C double bond C, C double bond N, N double bond N, nitro, azo, azoxy, etc. These compounds present in a compound, they are known as chromophore. They gives color to the compound. Now chromophores are of two types. See here one example, that is if only one C double bond O is present in the compound, it is colorless. Means it is not making the compound colored. But if two C double bond O is present in conjugation, then we can say this compound becomes colored. So C double bond O, which is not giving color when present singly, then it is dependent chromophore. It depends on another chromophore for color. Independent chromophore, N double bond N, nitro, azo, quinoid, nitroso, these are known as independent chromophore. If they are present in a compound, the compound becomes color. So same example, colorless is acetone and diacetyl is a colored compound, yellow color compound. So if chromophore is present in a compound, then it is called as chromogen. So chromogen is a compound containing chromophoric group. For example, nitrobenzene. A chromophore absorbs light in the visible region, so appear colored but cannot fix to the substrate permanently, so it is not a dye. Suppose this is a compound like diacetyl, but it cannot be used as a dye. When the fabric is dipped in this solution, it will not become colored. Why this has happened? So see this one example. Benzene, it is colorless. When NO2 chromophore is attached to benzene, it is becoming yellow colored. Benzene is a dependent chromophore, and when it is attached to the independent chromophore NO2, it becomes yellow in color. Now if to the benzene, which is a dependent chromophore, OH group is attached, which is not a chromophore, then it becomes pink color. Slight pink color will be observed. So it is now it is a colored compound, but it is not a dye. When this compound like picric acid, where 3 NO2 chromophores are there and 1 oxochrome is there, then we can say this compound is a dark yellow colored, which can be used as a dye because OH group is there which attaches to the fiber, because on the fiber COH group is there, on the fiber NH2 group is there, and they are going to be attract this OH which is oxochrome, and there is a bonding and the fiber and dye get fixed to each other, and hence this compound which is having chromophore and oxochrome can be only used as a dye. So oxochrome is a compound, or it is a group like OH, COH, SO3, H, NH2, which makes the compound dark colored. Means this deepens the color of the chromogen and fixes chromogen to the fabric by hydrogen bonding. And oxochrome itself is not responsible for color. To become a dye, a compound must contain oxochromic group. So dye is a chromogen carrying an oxochrome. Means there should be chromophore and there should be oxochrome to become a compound dye. Example, picric acid. Now we will see there are many types of classification based on various bases. Classification based on chemical composition. Now we know for a compound to be dye, there should be presence of chromophore and oxochrome. So depending upon the various type of chromophore, dyes are classified on various types. So we will see few of them. First, nitro dye, which contains NO2 as a chromophore, nitroso, which contains NO, azo dye, which contains N double bond N, indigo dyes, which contains C double bond O and C double bond C, stilbene dyes, which contains C double bond C and N double bond N as chromophores, phthalene TPM dyes, which contains quinoid as a chromophore, xanthine, which also contains quinoid, and anthraquinone, it also contains paraquinoid as a chromophore. So along with this chromophore, these compounds should contain oxochrome like OH, SO3H, NH2, NR2, then only it can be acts as a dye. And these are the various examples written in front of them. We will see one by one. Nitro dye. Example is picric acid. See, in picric acid, NO2 is the chromophore and OH is a oxochrome. Nitroso dye, which contains NO as a chromophore and OH or COH as a oxochrome. Then indigo dyes. Indigo dyes, it is having C double bond O, C double bond C as a chromophore, but NH as a oxochrome. Now you can see here two structures, both are same, but in royal purple there are two bromine groups attached to benzene rings. So due to the presence of bromine, this indigo, which is blue in color, it becomes purple in color. So see, there is a relation between structure and color of the compound. As structure changes, color also going on changing. Then these are the azo dyes, which contains N double bond N as a chromophore. So depending upon N double bond N, they are of many types. That is monoazo if one N double bond N is there, diazo if two N double bond N groups are there. So these are few examples which we are daily using indicator for titration, like methyl red, methyl orange, Congo red, which is a bis azo dye. Then TPM dyes means triphenyl methane dyes. Here 3 phenyl groups are there and 1 methane is joining these 3 phenyl rings. So malachite green is the best example of TPM dyes. Here more delocalization is color is there, so color is more intense, that is green color is there. Stilbene dyes are also containing C double bond C and N double bond N as chromophore, and SO3H group is a oxochrome. So it is having one example, that is sun yellow, which is yellow in color. Anthraquinone dyes, they are also of different types. It contains paraquinone as a functional group and as a chromophore. So here are three examples. One is alizarin. If one SO3H group is added, it becomes alizarin red. If instead of SO3H NO2 is there, then it becomes alizarin orange. Then phenolphthalein dyes, we regularly use during titration phenolphthalein. So we know from 11th standard phenolphthalein is acid base titration indicator, which contains paraquinone as a chromophore. So this is a structure of phthalene dyes. Similar to phthalene, there is xanthine dyes, which has dibenzopyran chromophore. There is a slight change in the structure, and therefore color is also going to be changed. Then there is another type of classification of synthetic dyes. This we'll see in the next lecture. Thank you.